So now what we're going to do is talk about waves. We'll understand what a wave is, we'll explain the parts of a wave, and we'll do some calculations on waves. So first of all, I asked in class, what is a wave? And there are many different examples of a wave. You've got water ripples, you've got the ocean, you've got sound waves, these are waves, the Mexican wave, and a wave like that. So title of today's lesson is going to be about waves. So first thing is, what is a wave? You need to know that a wave is something that will cause a disturbance which transfers energy, not matter. So you notice that you'll see the ripples when the stone falls in, and the ripples are moving outwards, but the duck doesn't move. It's because the matter is not moving, material is not moving, just the parts, just the energy. Okay, so two types of waves, a longitudinal and a transverse wave. Let's look at the transverse wave first. You will see that the wave is going towards the right, but the particles are moving up and down, up and down. Each individual particle only goes up and down, but the shape just looks like it's moving along the way, but it's actually only up and down. So this is a transverse wave. Longitudinal is the same idea, the energy going to the right, but the particles are now vibrating parallel. They're vibrating in the same direction as they travel. It's not going all the way along, which is what it looks like. No, if you look at one particle, it'll go forward, backwards. Each one does the same thing. So there's examples of transverse waves that I've mentioned, the ocean waves, Mexican waves, light waves, any electromagnetic wave. Longitudinal, you've got the sound, the earthquake waves, pressure waves, ultrasound, and so on. So back over to the transverse wave. The top is called the crest, the bottom is called the trough. The bit in the middle from the zero all the way to the top, this height is called the amplitude. It's not from the top all the way to the bottom, no, it's from the top to the middle, and the middle we will call the null position. So in a longitudinal wave, I've already mentioned that the coil will go backwards and forwards along the same direction, and bigger amplitude means more energy will be carried by the wave. That's true for both transverse and longitudinal, actually. Okay, so I've explained what the amplitude is from the center point. A wavelength is the distance between any 2 points. We can have two crests from here to here. This is one wavelength. You could actually also do two troughs as well. We could do two bottoms, as long as it repeats the same motion you get from the same place. This is also a wavelength right here. You can also say the wavelength will start from the middle all the way up, back down, and right back to the middle again. This is another wavelength, and the symbol is lambda. This is wavelength. Okay, so either of these will work. The phase is the exact position of a wave, so each wave will have a shape and position. If you get two waves that meet together and they look exactly alike, they will match and overlap, that is in phase. Otherwise it will be out of phase if they don't overlap exactly, completely out of phase if they cancel each other out, if they are opposite each other. If you wanted to find the frequency of a wave, you have to know how many waves, how many cycles have passed a certain point, and then you divide that by the time it takes. So frequency is n over t, the number of waves divided by the time. For example, if I show you this wave in a time of 1 second, you can see that, well, how many waves do we have? We have 1, 2. That's 2 waves in 1 second. You will do 2 divided by 1, and that will simply be a frequency of 2 Hertz. You can do the other 2 yourself. You can also calculate the speed of the wave by doing distance over time. If you know the distance that the wave has travelled, divided by the time. If you know the wavelength and it goes through one full wave, the wavelength can be your distance. Another way to find speed is V equals F lambda, the frequency times by the wavelength. So if you calculate one of these two, if you find frequency doing n over t, then you can use it in this formula to help you find the speed or help you find this wavelength. You can rearrange this formula. There were some examples that we tried, and then we moved over to graphing waves. And what's the wavelength of this wave? If you were to look at this graph, the wavelength is from the start If you started here, this is the middle, so go all the way up, all the way down, and here. This is one full wave, and that's 40 meters. Amplitude would be the height, so that will be 3 meters. So this will be 40, and then this one will be 3 meters. Easy.